rather you do it right now when you have the.
You said after club, right?
We have a tournament.
I did not say that. No.
We have a tournament Friday, so when do we make it up?
Yeah. Will that affect
Then you'll have to
our
do it when you come back.
grade? But will it affect our grade?
But we'll test Friday.
Will you put a 0 in though?
I'll put a missing. Yeah. What are your questions?
Literally costs so much.
Or we could test Thursday.
No.
No.
Because we'd be done today. You just have to review.
I need.
I'm not ready.
How are you not ready? It's not even.
Mine, I think I was bit by an ant.
What exactly is the test on?
Yeah.
Chapter 4.
The whole thing, like the equation.
Everything. Chapter 4 is not hard. Peyton, what are your questions?
Oh, I didn't have a question.
Oh, awesome.
When did you do that one?
9.
She missed
It
it.
was 4 or 5, right?
That's
Yeah.
what we did yesterday.
Question 9. Is this the one we did?
We did it?
No.
What?
Oh.
Oh.
Will this
Yeah,
be a test?
and it was wrong, huh?
Well, you have to add the thousands.
Oh, it was picky. Okay. Alright, so they give you some information over on this side. They're telling you that the price are these, and then they're telling you that the size and square footage is this here. And now be careful here because what these prices are actually in thousands of dollars. In thousands of dollars. And that's kind of the I got you there. So, anyways, they give you all these values. They also give you an equation that represents the price, which is right there. Now, if you come over here and plug in simply the prices, because that's what you have here, right? You're just going to go 122, tab, 130, tab, 158, and that's pretty much the system there, because you've got 3 equations for price. Check that answer. We're good to go. Questions there? All right, cool. So, and then it's asking us, what's the selling price of a house with 1,600 square feet? Well, what you have to do is you're going to have to solve the system. Because what it's having you do is create an equation and find A, B, and C. And you can just do that using your RREF. So that's what I'm going to do. Save some time here. Go away to the screen. Let's see here. I'm trying to move this out the way. Here we go. So I'm going to go to, where do I want to go? Matrix. Second matrix. Had a senior moment there. And this is going to be a 3 by 4. Okay. So here we go. We're going to have 1, 1,500, 8, 122. And then we've got 1, 2,000, 5, 130, 1, 2,200, 10, 158. So at this point, I'm just going to go and reduce row echelon on this. So second matrix, I want to math this bad boy. Stop saying that. I want RREF, and I want to reduce matrix A. So here we go, RREF, matrix A, for center, and here's my solutions. Now I'm checking, make sure that this is the identity matrix. If this is not the identity matrix on the left, then there would be no solutions there. So what this is saying is that the value of A is 30, the value of B is a 0.4, and then the value of C is 4. So what I can do with that is I can create an equation. And they kind of gave it to me here. They're saying that P is equal to A plus B S plus C big C. So P is equal to 30 plus 0.0404 S plus 4 big C. Questions on that equation where it came from? Kyle, we're good? Raina? Okay, so all I have to do now is plug in the values that they gave me. And what they told us was that this house was 1,600 square feet. So in here for S, we're going to plug in a 1,600. And I think that the shape it was in, is that what C was for? The condition is a 7. So don't do that. So C will become a 7. And I just used my calculator to do it. So I went 30 plus 0.04 parentheses times, what is it, 1000, right? Plus 4 times 7. So there's the whole equation. And this is where I got it wrong yesterday. I just went 122 and pushed enter, but it doesn't want that. It actually wants the cost. So if this is in thousands of dollars, then I need to add comma 123, so that it's $1,000. And that's why, so there it is, okay? Questions on any part of that? Systems. They really do help. I mean, when you're starting to work with businesses, anybody going to go into business? Okay, you're gonna use this a lot. And when you get to calculus, you're not gonna take there's like 2 versions of calculus. There's like calculus 1 and there's calculus 2 where people that are going on a math route would do that. You're gonna do something called brief calc. And you're gonna do a lot of stuff with systems because putting stuff into the equations, like your business models for your cost, your employees, all that is a separate equation. So you have to be able to manipulate those. So this is a big deal for you. So you're gonna get to use this a lot. That's where I learned to use my calculator for that kind of stuff. It was most funnest. Did you notice the enthusiasm in my voice? Yeah. I was kind of mad at the end when then she says like, "Oh, we can also do RREF." I'm like, so now I don't torture people because it feels that way. You know, kind of like after you after they make you do long division and they're like, "Well, check out synthetic division," and it's like, "What?" You guys remember synthetic division? What is that? Oh. All right, what else you got? What else you got? Is that it?
Can you do some of the matrix ones?
Like, or?
Like, I don't know where they were, but.
Oh.
Like that?
Sure.
Well, that one you can put in the calculator, can't you?
You can. Find the inverse matrix. Well, what you'll have to do is you'll have to, yes, you can do it by your calculator, but you also have to learn how to do it by hand. So that's kind of the idea. And what you'll have to do is to do the extended matrix here.
How's that right?
It could be. We have to extend this, make it, what is it? 1, 0, 0, 0, 1, 0, 0, 0, 1. And then through row operations, we have to make the right side look like the left side. Okay? And is that the part you need to see? Okay. Then I'm not going to do it here because I'm not going to have space. Let me clear this ink real quick. Yeah. What do I want to do? Take a picture. And yeah, you could throw that in your calculator, but I would suggest that you use your calculator, Josh, just to check your work. Make sure that you did it correctly. You're going to have to know that skill at some point. All right, cool. So let's start with this. Then I'm going to expand it. So 1, 0, 0, 0, 1, 0, 0, 0, 0, 1. All right, so first thing first. I need this to be a 1. That 2 needs to be a 1. So I'm going to multiply this whole column by 1/2. That's going to give me 1, 0, negative 1/2, 1/2, 0, 0. And do the other columns change? No. So I've got 0, negative 1, 0, 0, 1, 0, 3, 2, negative 2, 0, 0, 1. Okay, what's the next thing I need to do? Well, that 0 is already done for me, right? So, good to go there. I need this 3 to become a 0 now. I need that 3 to become a 0. So I'm going to take row 1, multiplied by a negative 3, and add all of those numbers to row 3. Okay? So I'm going to write them right below. Is that cool with you guys? So this should give me a negative 3, correct? And then 0. And then what's a half of 3? What's it, 3 halves?
A half of Yes.
So it should be, or here, let's do this. Let's do that. Let's go 1.5. Because that way I can do it with the whole number. And then I'm gonna get another, I'm gonna get a negative 1.5 here. This should give me 0 and 0, correct? So I'm gonna double check that. Yeah, thank you. All right, cool. Move on. So let's combine those. Does row 1 change? Nope. And then I've got, let's see, I need this to be a 0, negative 1, 0, 0, 1, 0. Okay, let's add them up. 0, 2, negative 1/2. Well, that's just going to be the whole thing, isn't it? So negative 1.5, 0, and 1. All right, cool. Next thing I need is this negative 1 here to be a positive 1, correct? So all I really need to do is change all the signs, don't I? Because what I can do is multiply row 2 by a negative 1. So let's do that. That's 1, 0, negative 1/2. 1/2, 0, 0. Like there's not enough space here. Alright, cool. So in the middle row, that's going to give me 0. That'll give me a positive 1, 0, 0, negative 1, 0. And then I've got 0, 2, negative 1/2, negative 1.5, 0, 1. Okay? Okay, so we're here. Next objective. We need to make R3C2 into a 0, right? So R3C2 needs to be 0. The way I'm going to do that is I'm going to make some space first. Okay. Let's take row 2 multiplied by negative 2 and add it to row 3. Will that work? Yeah? All right, so that's 0, that's negative 2, 0, 0, positive 2, 0. Okay. All right, cool. Here we go. Row 1 doesn't change, so I've got 1, 0, negative 1/2, 1/2, 0, 0. And I've got 0, 1, 0. And here we go. So 0 plus 0 is 0. 2 plus a negative 2 is 0. Negative 1/2 plus 0 is still a negative 1/2. That's still negative 1. Oh, did I just skip this whole middle row?
Yeah.
There you go. There we go. So negative 1.5, 2, and 1. We're good? All right, cool beans. Now, last step. I need a R3C3 to become a. Oh, you're right. It's not the last step. So the next step then is to make R3C3 into a 1. And I'm going to do that by multiplying this whole row by a negative 2. By a negative 2. Okay. So 1, 0, negative 1/2, 1/2, 0, 0, 0, 1, 0, 0, negative 1, 0. Here we go. Multiplying by 2. 2 times 0 is 0. 2 times 0 is 0. Half of 2 is 1. So negative negative makes positive. Negative negative makes positive. And if I multiply this by 2, I'm going to get 3. And then negative 4. And finally, negative 2. Now the final step, right? Final row operation is to make R1, C3 into a 0. So R1C3 needs to become a 0. How? Yeah, that was my bad. Someone corrected me. These guys over here. Did you correct me?
No, I have the answer right here.
Oh. It might not make a difference here. It might not, but we're going to take a look anyway. So we're going to take this last row, row 3. We're going to multiply it by negative 2. And then add all those values to row 1. Right? So here we go.
It's wrong.
I'm going to... What happened?
No.
Your calculator's wrong?
No, it's right.
Okay. Don't scare me. Don't get ahead of me.
Quiet.
All right, so negative 2 times 0, it's a 0. That's a 0 also. That's going to give me a negative 2. Oh, that's not going to work.
Do you want to see the?
That's not going to work.
Peyton, be quiet.
What should I have multiplied it by? Because I'm adding it, right?
That's your getting up. Like, oh, thanks.
So it's going to be, yeah, so it should be, is it a positive half?
Oh.
Yeah, so multiply by half. That will turn into a positive half. Yeah, that works. Should work. Okay, so here we go. It's still going to be 0, 0, a positive 1/2. Half of that is 1.5. 1.5. Half of negative 4 is a negative 2, and half of negative 2 is a negative 1. So let's combine them. Now, I'm not going to write the whole thing, because all I care about is this last column, right? So I should have a negative 2, a 0 there, and then when I combine those, I should have a negative 1 here. So, since you already have the answer up, negative 1, 0, negative 2?
Yes.
Awesome. So, we'll take those 3, since that's all we care about.
Oh,
Negative 1, 0, negative 2.
what?
Plug them in here. I feel like that's wrong. Is it wrong?
Oh my god.
Negative
Yeah,
1,
No, I seriously.
0, negative 2.
We heard you do millions of
It's
times.
actually right here too.
Math. Okay. And it's recorded if you want to go back and watch it with more detail. Yay.
And cry while we watch.
Don't cry. You don't want to put water near keyboards and electronics.
Mine's water.
Nothing in the water.
Maybe around a lemon or a saladito. You know, a little salt in there. It'll be okay.
Why is
Oh, I
it the
love
same
when
as a
it's
third
all-
column?
we
on this
might-
board?
Coincidence? It almost looks like the whole thing is the same, doesn't it?
Lemon with my water.
That's mind blowing.
What?
Because remember last time we did a few of
Oh
these
my
and they were all fractions, right? So in this case, just the way the numbers lent themselves.
Wait, I'm so confused. The answer's right there.
Yeah, they are the same, and even the first row is the same. But the
Oh,
middle,
no,
but the
not
middle
the
one's
middle.
different.
I was like,
That's mind blowing. That's cool.
I don't have that.
All right, cool. Are we good here?
Peyton.
Any other questions? Any other questions? Calibert? All right, cool. We're done then. Close your laptops.
No, I don't have.
Let's take some notes.
No.
Yeah, notes.
Movie day.
There's no movie day.
One day.
You have never got, no, you will never get a movie day.
One day.
We did last
Why
year.
not?
It's stats. It was the dumbest movie I ever watched.
Which one?
It was like the little animated one.
The Donald and Matt Magic Land?
Yeah.
That's a great movie.
It was like 2.5 hours.
No, it was. It was
Let's watch it and let us be the judge of that.
No, you don't want to watch it, bro.
Donald and Matt the Magic Land is a great movie. It's a classic.
What
Maybe
did-
we'll watch The Man Who Knew Infinity.
What did he say that you started cracking me up?
Square roots.
What?
No?
I'm like, okay.
Alright.
Well, what do you know? Square roots. Where is it at? Here we go. Okay. Chapter 4, Section 6 is the last section. Dealing with matrices. 4.6, what we're going to do is we're going to talk about determinants and Cramer's rule for solving linear systems. So we're going to evaluate a 2x2 determinant, use expansion by minors to evaluate a 3x3 determinants, and understand the derivation of Cramer's rule. Apply Cramer's rule to solve linear systems. Can you close your laptop, please? Just close it.
I need to charge my
Then put it back there somewhere, away from you. No one's gonna take your phone from you.
What is the treasure photo?
No one wants to see your Snapchats.
I don't have that.
Good.
Oh, my back.
Okay, here we go. Evaluate determinants. I think I already told you how to evaluate determinants. What? No, that's not the determinant. Here's what you're going to do. You're going to take this diagonal, you're going to multiply those two, and subtract from that the product of the other two diagonals. So you're just doing like an X. It's simply that simple. Let me just not show you the, what do they call this? I forget. Where it's juiced up. But it goes like this. That's funny. What is -1 times -2? It's 2, right? Good. So there's the diagonals that go from top to bottom. I'm going to subtract from that the diagonal that goes bottom to top, which is 4 times -3. How much is that? How much is it? -12. So what is 2 minus the -12? You're done. You're done. That is the determinant. That is the determinant.
That's all you do?
That's it.
Two?
I feel like it gets complicated.
Okay? You guys cool there?
Is this as bad as it gets?
No.
Okay.
But if you get that, you're halfway
Is
there.
it minus everything?
So what I'm doing is I'm taking the diagonals that go top to bottom, and I'm subtracting the product from the ones that go bottom up. Okay? Questions there? That was simple, right? You want to do another one? Or do you think you got this one? Because this one's okay. Do another one like this?
One more.
I'll make it up. Give me some numbers. 9,
3,
3, -2,
one.
1. Good. Okay. Remember the colored pencil I was talking about? They help. Okay? Or highlighters. What is this product?
9,
I'm going to take 9, subtract from that the next product, which is -6. How much is that? 15. You're done. That's the determinant. Are we good?
That was easy.
Okay, you guys ready? Now, this is a 2x2. Things are going to get much more complicated with a 3x3. Okay? But it's the same idea. Now, I'm not going to show you their way here because this is what they like to get kind of crazy with stuff.
No.
That's my sentiment exactly. So I'm going to show you what made sense to you. Is that cool? And we're going to grab the determinant from this bad boy. Okay? Now, do you remember how the 2x2, when I cross multiply, there was 2 numbers? Okay? Here, Simon. Here, if I want to find that diagonals, this time there's 3 diagonals. Here's 1, here's 2, and technically here's 3, correct?
0 says.
There's nothing there, right? Okay, so here's how we're going to fix this real quick, before we can get those diagonals.
Why wouldn't it be
Go ahead.
this like an X?
It kind of is like an X, but it's not just one X. It's going to be a couple of X's. Okay?
No, I'm saying like 1, -2, -2 that way.
1, negative 2, 2.
The other way.
1, negative 2, negative 2.
Yeah.
Well, there is. You're going to do, it's kind of like this, and then we're going to subtract the ones that go like this. We're going to do that. But, yeah, because this is a 3 by 3, we're going to need 3 different ones. So, follow along, and you should be hunky-dory. Okay? Because, remember when I made those diagonals, there was numbers missing? So what I'm going to do is I'm going to extend the matrix. I'm going to copy the first 2 rows at the end here. So 1, negative 1, 1. 3, negative 2, 1. All I did was extend the matrix so that can make it easy for me. I could show you the way they do it,
No.
which is not as nice. Okay? So everyone cool with this? Okay? I'm going to draw the 3 diagonals, and I'm going to use my highlighter here. So you can see the 3, okay? So, here's one row. Do you see it? Here's another, and there's a 3rd diagonal. So now I've got numbers there, don't I? Don't worry about the leftover stuff up there. We're okay. We've covered them all. You guys ready? So, what is 1 times negative 2 times 2? Negative 4. Okay, we're going to add to that the next row in yellow. So 3 times 3 is a negative 9. And negative 9 times 1 is just a negative 9. And we're going to add to that the 3rd row, the 3rd diagonal, which looks like it's just going to be 2. Okay? All right, cool. So remember how we did the ones that go top bottom minus the bottom tops? So at this point, we're going to subtract, because now we're done with those. So let me show you the other 3 rows. Highlighter, I'm going to use purple here. There's 1, 2, 3. See them? Not so bad. Okay, so now let's get, whoops. There's the other 3. So let's look at the first diagonal. What is 1 times negative 2 times negative 2? It's 4. And then what is 1 times negative 3 times 1? Negative 3. And then I've got 2 times negative 1 times 3. Looks like negative 6, correct? Cool. Let's do it. That's it. Just clean it up. So this looks like it's going to be how much here? Well, be careful because you got a negative that you got to distribute out there. It's the product of that. Okay, kind of like it's that bit. It's all these minus all those. So this looks like negative 13 plus 2, so negative 11. So negative 11 minus, what do we got? Negative 9, negative 5? Right? Double check that. So what do we get? Boom, we're done.
Is that the worst it's going to get?
Yeah. Unless we do a 4x4.
Oh.
JK, smiley face, LOL. Oh no.
No.
Don't do that again, buddy.
We laughed so
Okay, let's take a look at, because I need to take a look what they did here. So, let me.
That's all we're learning today?
No, there's more. But I wanna, if this makes sense to you, I wanna show you this other way, and it will make sense hopefully. From
Do we
Glenn's
have
life.
to listen to them?
No, you don't.
Okay, good.
No, if you got what I just said, but you're curious anyway, like Steve's
I'm
so
gonna
curious.
confuse myself.
Okay. It's really not that bad. Let me show you what they do. Okay. Do you guys see the one here? That's the same one as this. And what happens is they cross out the rest of that row and the rest of that column, and the matrix that's left behind is what becomes the matrix right here. You see that? Okay. And we're going to subtract from that. We're going to subtract from that, and then we go to we'll do it again. So everyone's cool with that, correct? Oh, sweet, that worked. Then we go to the next number there, which is a negative 1. Same negative 1 as this right there. You get rid of the rest of that row and the rest of that column,
and those other numbers are left behind, produce that matrix. See it? Okay.
How do you do that?
And then the last one, let me erase this. And then the last one is this one, which is the exact same one here. Excuse me. Okay? And then we get rid of that row and the rest of that column, and the matrix that's left behind is the matrix that goes right there. Okay? From there,
You go ahead and multiply the scalars. So there's going to give you your -2. Whoa. Yeah. Craziness, right?
Oh, this is their way of doing it?
Yeah, this is another way of doing it. There's nothing wrong with that one. I've never been a big fan of it. But if you're really interested in knowing it, come see me after school. I'm going to stick with my diagonals because I like them. They're cleaner for me. Okay? All right, cool.
Oh, that was their way.
Yeah, that's the other way.
Yeah, you scared me.
Yeah, no, you don't have to do it this way if you don't want to. Okay? And yeah, what they call it is minors. They do minors. So they do minor matrices with it. Let's see here. So it's 1.
Oh, okay. So they're just gonna be there.
Okay, so it's kind of the same idea.
here's your -2 times 2, and then there's your minus 1 times -3, and it gets multiplied by 1. And over here you got negative, which is a 1. So you go 3 times 2, 1 times -2. You see how the potential for making a mistake there? So I'm not a fan of that.
That's the same thing that we just did?
Yeah, didn't we just also get -6? Yes, Josh, I'm always going to show you the easiest way that I know. Okay? Always, I promise. I don't like making stuff hard for people. Okay? All right. What's this say? To continue? Oh, they're just going to go for, were we going for the value determinant using expansion? Continue. What are they doing here? They're trying to find the inverse? Yeah. I don't know why. They didn't tell us to. Okay, and we already did this. Use inverse matrices to solve systems of linear equations. Okay. No way, was that it? Woo! Oh, that's it. We're done.
Hey.
Hip hip hooray! Hip hip hooray!
Remember
Remember that, Layla? From Kendrick from preschool. No? Oh, that was one of my cheers. That
I
was one of my cheers with the kids. We were like, hip hip hooray! Hip hip.
I was so spoiled in Head Start.
Oh yeah. I bet
No,
you they
I
all
was
spoiled you. Huh?
because I wasn't at my mom's Head Start. I was at her best
You
friend's.
scared me.
And you know how you're not supposed to cross the red line? I got to go in the offices and sit there. Yeah, I was spoiled.
All right, let me end this because we're done. Stick a fork in you.
You guys can fuck off.
Whoa!
Funny mom.
I cannot stand
Hey, you know what? This is not right.
What is not right? No, that language.
The lesson is not right. We're supposed to solve.
Oh.
We're supposed to solve.
I like what we just did.
That was pretty easy though. I think we should just skip.
Yeah, they don't have the whole thing here. That's what I'm saying.
That's
No,
Kramer's
you're fine.
rule.
That's fine.
Well, you need to know how to solve them using this, okay?
That's
So-
all they want us to learn. That's all we got
We
to
just
learn.
learned how to solve it.
No,
No.
no, you didn't. So let me. It's 8:50. I'm gonna do one real quick with a 2x2 system, and then I'm gonna show you guys because I think I showed you once already anyway. So you guys should be okay with this. And then we won't have time for the 3x3. It's not gonna happen today, so we'll do that tomorrow. It's starting to look like we might have to test after the break.
Hey, you're nice.
No, it's not.
You said no.
I really wanted to end the quarter with the test,
But
but
it's okay.
Oh, just give us the point there.
system.
Oh wait, you're gonna put this into our first quarter?
Bro, my grades suck.
These all go in your first quarter.
This
No, the first quarter finished Friday.
Oh,
Oh, sorry, I wanted to finish before
Yeah, I was
break.
like-
Sorry, I know.
I was
Okay.
like, what?
My bad. My bad.
Funny mom.
Worksheet. Oh. Okay. All right, let's do this real quick. Let's do it.
Bitch, I just didn't talk. Really? I could talk. Like I could.
Why are these all
I just
weird?
wouldn't talk.
I don't want that.
Yeah.
Doom, doo, 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 doom.
No,
All right, cool.
I already talked to the editor. Not talk.
Okay, you guys ready? Here we go. Let's make the first matrix. 5, 1, 10, -7.
Oh.
And then, of course, the answer ones would be 9, -18, right? All right, let's find the determinant first. And that's simply going to be, what's 5 times -7? -35. Subtract from that 10 times 1, which is 10. So that means that the determinant is how much? -45. Good. Okay. I'm going to make this a little bit smaller here, because I think I can fit them all side by side. Do I really need to show you guys this? You guys can see it, right?
Yes.
All right, it's gone. Okay. I'm going to make this matrix again. But because I'm going to find what I'm going to call dx here, I'm going to solve kind of like for the determinant with x in it. The answers are going to go into the x column. So 9, -18. Okay? And the other column stays the way it is. So I've got 1, -7. Okay? Questions there? All right, cool. So what's 9 times -7? -63. -63. And then 18 times 1 is just -18. So what's dx? You've been watching too much WWE. -63 plus 18. Nobody move! I'm trained for this. How much? -45. All right, cool. So, you guys good? Now I'm going to do it one more time. I'm going to call this guy dy. The x's are going to stay the same this time, 5 and 10. And in the y column, I'm going to plug the answers in. So 9, -18. So something minus something, right? 5 times 18, or 5 times -18, is -90. And then that's going to be 90, right?
So all you do, like, in the first column, well, it don't matter really, does it? Which order?
The first one, yes, it does. You want x's here, y's there. Okay, and then when you get to the dx, the x columns become the solutions. See that? And then the y column stays the way it is. When you do dy, the y's become the answers, and the x column stays the same way.
But, like, does it matter if we put the dy instead of the dx?
Oh, if you do dy column first? Nah. Because I'm going to take those values, I'm going to show you the solution in a minute.
It's just the same, isn't it, either way?
Not really. They're not the same matrix. Because remember, you got to get your solution is 1 point, which is x comma y. And that's why I do x and then y. Okay? The only reason. But if you want to do y and then x and then swap your answer at the end, cool. What is that, -180? Right? Okay, so it goes like this. I got those 3 numbers, that's what I need. The solution is dx over d, dy over d. So -45 divided by -45, 1. -180 divided by -45. 4?
No, it's yeah, it's
4? There it is. We're done.
Oh, yeah.
That's it. That's how you solve a system using the determinants. I'm going to go entire page. It is. It's not that bad. Yeah. So you guys solved it. There it is. At the end, the answer is going to be dx over dy, dy over d.
It is from 7 to 10.
I definitely don't have time to do a 3x3, but it would be the same idea. You would take the original one, find the determinant, take all the answers first for x, and then for y, and then for z. That gives you three different dx, dy, dz. Divide them all by d, and you're good to go. Decide. Oh, thank you. I'm going to stop this recording real quick.